Hello and welcome to Beamer Folk. I promise you this is not the beginning of a reality show. I purchased one of these inexpensive component testers and of course it doesn't come with an enclosure. There are a number of videos by other people regarding fitting these boards into an enclosure. But it's a particular passion of mine to find upcycle enclosures that we would otherwise throw in the trash bin. And this I thought to be quite a good marriage, that is between the component tester and a polypropylene enclosure of a very good size for it, that was a cotton bud box, and it's fitted this purpose very well. So I thought I would share this with you. This is the first of 12 slides that I'll go through to describe how I've assembled, constructed, made this small project. First of all, the component tester itself. It has attached a PP3 cable assembly. The next is a battery holder containing 3 AAA metal hydride cells. So that will produce about 4.5 volts. So that will need to be boosted up to the required 9 volts for the component tester. You can't go beyond, I think about 10 volts is the maximum you can supply this component tester with. So here is a boost converter, and I've pre-adjusted it by connecting it up to 9 volts. And it is the ubiquitous M for mother, T for Tommy, that's MT 3608. That's MT3608 boost converter on a printed circuit board, quite a small thing. Next we have the enclosure itself. Well, of course, as I said, this is a cotton bud enclosure. Well, it was a cotton bud enclosure, and at the top here I've cut to size a cardboard tube as it's a center core for an aluminium foil tube dispenser. You tend to throw them away, and of course I like to upcycle it, and that's what I did, cut it. And in fact it cuts very well with a hacksaw blade. Just sort of measure it off with a pencil and then cut across it. Cuts quite easily, and this battery holder fits in there very well. All I did was to put a little bit of foam on one end to arrest the battery holder to one end, and it worked fine. Okay, so I'll move on to the next slide, which is here, and this is demonstrating partial assembly of this. When working with this polypropylene box with a spike, just pilot the screw holes here and here, there, and the switch hole here with a spike. It's a little bit of a delicate exercise. If you're too aggressive with it or punch at the spike too strongly, the plastic will crack, as happened here. It's not a problem, because by the time the bolt and the washers have been assembled around it, it holds itself quite well and doesn't run. You could, I suppose, address this with a bit of glue, but I didn't feel as though it was necessary. It didn't detract from the strength of the box. You can also see that I've cut a slot into the side of this cotton bud box X, and I did that not with a pair of cutters. If you try a pair of cutters, you're likely to have a fracture run down the side of the plastic side. So what I did was, with a file at about a 45-degree angle with nothing else, of course, in here. I filed down, I think I used a rat tail file to begin with, all the way down to a point which is about 2/3 of the way down. It has to be 2/3 of the way down because the lever over here of the component tester, when switched horizontal from a vertical position, needs to lie across there horizontally without being interfered with by this plastic. So the setting of these support nuts is important to the final assembly of the component tester. And as you can see here, I've installed, again with a similar process to the spike punching hole business, a single pole toggle switch. To drill out the actual final holes in the box, I used a hand drill, if you like an old grandfather hand drill. I find it's the best for this type of purpose simply because you have very good control of it and you don't over drill. You can feel your way through the plastic, and I find it ideal for that. As you can see, there's a demonstration here of how the battery holder fits nicely into the cardboard tube. I used, incidentally, washers either side of the plastic box. That gives added strength. And the switch is positioned so that the body of the switch here is below the final nut. This is so that it doesn't actually interfere with the printed circuit board. Go on to the next slide. Right, this is simply demonstrating the assembly of the board into the enclosure itself. And as I described just now, the horizontal position of the component clamp. Anything else to say there? No, I think that is complete. Oh, the 4 holes, the alignment of these 4 holes here on this printed circuit board, I found to be neither metric or inches, somewhere in between. In fact, I had to use a vernier to get the exact dimensions of these 4 holes, and yours might be slightly different. The alignment of this board needs to be such that the push button here doesn't exceed the height of the box. So the nuts underneath here do need to be quite critically adjusted so that everything fits nicely together. Another slide showing how the cardboard battery holder container fits nicely into this position here. I did incidentally finally clean all this up. It's looking a little grubby, isn't it? Next slide. Yes. Okay. Well, I used a glue to glue. There was an additional drill hole here that had to be placed in, so you can fine adjust the 9 volts on this board. It's best to do this beforehand because this adjustment can go up to about, I think, 14 or 15 volts. So I wouldn't like to apply that immediately onto the component tester. So I pre-adjusted this to 9 volts approximately. And when, of course, I finally assembled the whole thing together, I did a little tweaking of this so that I got exactly onto 9 volts, which incidentally this unit actually tells you the supply voltage. So that's handy, isn't it? You've got an inclusion here of my little feet that I put underneath just to hold the thing up from the surface, because you really wouldn't want the bolt ends here scratching anything. So that's what I did. Right, I move on to the next slide. Okay, this is my initial wiring. You've got here from the battery holder, which is soldered onto the ends of the battery holder. A little tricky because if you overheat the metal on either side of the holder, it will tend to lift off if you apply too much heat for too long. So it's best to be as quick as possible. And I used a file just to expose the surface of the metal before I soldered. And then I soldered a red and black wire accordingly to the positive and negative of the battery holder. The negative of the battery holder goes straight to the negative in of the 3608 board, and the positive wire goes via what I've used as a fairly simple cable clamp here. I've wrapped the wires around there, and the positive wire goes into the one positioner switch, and then on the output of that switch I've taken that through to the positive VN of the 3608. The glue that I used to glue the board in was the flexible clear glue in a tube that you can purchase from a store here in the UK called Poundland. Okay, we're now on to this slide, and what's the thing I need to point out here? Oh yes, I replaced the PP3 cable assembly with a couple of wires. That's a white wire and a yellow wire, and they go to the boost converter board here, the MT3608, the output of that board, which is of course 9 volts, and that goes straight into the component testing board. The positive wire, there's a very small symbol on the board here which says positive, and that is the yellow wire. Next slide. This simply shows you that I've used a tape as a hinge. I couldn't think of a better thing to do, and in fact actually it works quite well. I used a tape, quite a strong tape, which again was from our Poundland store, and it's a carpet non-slipping, and it's quite a tough strong tape and grips quite well, so I thought it would make quite a good hinge. So I'll now move to, I don't think there's anything else to be said on this slide, so I'll move to the next one. And here we are, and you can see the nature of this tape. It's actually quite thick and behaves as a hinge quite well. And you can see how the lid is closed onto this. None of the components on the board actually extends to the lid. There's, I think, probably a 1/16 or a 32nd of an inch gap between the top of the lever here and the lid itself, but it actually all fits in there quite nicely. I'm quite pleased with it. So I move on to the next slide, and this angle demonstrates, the picture's not brilliant, it demonstrates the hole at the front where you can put a small screwdriver in there just to make fine adjustments over the 9 volts. Try not to extend that beyond 10 volts. There is risk of damaging the component tester, and I would say don't go below about 7 volts. I think the component tester would start to misbehave. On to the final one here. I think it's the final one anyway. There's one more. Okay, this is me demonstrating that a electrolytic capacitor here, I think a 47 microfarads, works, and you can see the board working quite nicely. And as you can see, 45 microfarads. I've been slightly short-changed there, haven't I? With an equivalent series resistance of 1.4 ohms and loss of 1.1%. These are actually very good, inexpensive little boards. I've been quite pleased with it. Okay, I've just had a thought. I haven't done this, but it could be advisable, and that is that I haven't included a fuse holder. You could put in the positive wire here in series a fuse holder and snuck it round the back here inline. So it's an inline fuse holder, 20mm fuse holder, set at about, I would think, about 0.5 amp fuse, and it would just protect the circuit if ever there were a short circuit occurring on this board. As I said, I didn't employ it, but I think if you were really being safety conscious, one would probably do that. This board is a little exposed, as I've discovered. From my perspective, I thought, well, if it gets damaged, it's relatively inexpensive. I could very easily buy another one. But if you are more safety conscious than that, the correct perspective. And I did notice that as you move components in around here and play around with components, it could quite easily, the leads could, a component could easily drop and maybe short something out and cause a problem. But that was a risk I was prepared to take, but I don't necessarily recommend it for other people. So all you'd have to do is put a inline fuse holder in there and you would be safe. I think I've got one more slide. And there it is. This shows the underside of the unit, and you can see the 4 feet there protruding. And you can also see the yellow and white wire, how I've soldered it onto the output of the MT3608. Finally, all that remains to be said is that we wish the happy couple longevity. This is Beamer signing out for now.